Hello, algebra students, and welcome back to another video lesson as we begin the second part of Chapter 12. And we look at how we can use some of these different forms, standard form and factored form, to help us find solutions, intercepts, y-intercepts, things like that in our parabolas. And so today we're going to convert from standard into factored form, because remember, factored form gives us those x-intercepts quite easily, and we're going to use a process called factoring. Now, in order to help us understand where we're going, we got to kind of understand where we've been, right? These are all in factored form. Now let's think about how we convert them back to standard form. Why don't you pause the video here and try to multiply those, putting them back into standard. All right, standard form. I use the rainbow method where I take x times 2x. So that's 2x squared. The x times negative 5 out front is negative 5x. This 4 times 2x is positive 8x. This 4 times negative 5 is negative 20. And then we've got to combine like terms, this one and this one. Or we get 2x squared plus 3x minus 20. So that is now standard form. A is 2, B is 3, C is negative 20. We can tell it opens up and things of that nature. Now, the other way that we did those problems in the past, the other method, was to create a box method. And this may be helpful. Sometimes it's called a diamond or a box, but this might be helpful for what we're doing for factoring. One of those parentheses, or those factors, go over here, 3 and negative 8, or 3y negative 8. Up here is 4y with 6. And then we multiply the cross section. 3y times 4y is 12y squared. 3y times 6 is 18y. Negative 8 times 4y is negative 32y. Negative 8 times 6 is negative 48. And then we can combine those like terms. We get 12y squared. If I combined these two y values, negative 32 and 14, leaves me with negative 14y. And then we've got this minus 48 on the end, which means that it has been simplified. And so you can use that box method, and we're actually going to talk about how this helps us, how this helps us to factor. The last one, remember, whenever we've got that squared part, we want to write this out twice so that we can definitely see we've got 4 multiplications. X times x is x squared. X times negative 3x is negative 3x. Negative 3 times x is negative 3x. Negative 3 times negative 3 is plus 9. And we have x squared minus 6x plus 9. All right, that's how we convert this information back into standard form. We started with factored form, the factors. We're converting it. But what we've got to look now today is, how do I take these results that we have here at the end? How do I take standard form and put them into factored form? Right? Because that factored form helps us with those x-intercepts. And so this is a process that we're going to call factoring. Right? How do I take this standard form and turn it into this factored form? Now, if you look at this, I want you to pause the video in a second and take a close look and see if you notice any patterns here. Is there anything that you might recognize? All right. Well, one of the things I notice is that if I take these last two numbers here, 6 and 10, and I multiply them, I do end up with the C value. So if I multiply these last two numbers of the factor, I get C. Well, what happens if I add those two numbers? I got B. And we can use that knowledge to help us factor, but we can also use that knowledge in the diamond or the box method, okay? In this kind of box method. And what that means, if I were to create a box, we can put the first term in the top left, x squared, and we can put the last term in the bottom right, 60. These two empty boxes right here, they need to multiply to 60, right? Multiply up to that last part, 60. But at the same time, they also need to add up to 16, the B part. So two numbers that multiply up to 60 but add up to 16, well, that would be 10 and 6. Right? 10 and 6 is 60, 10 plus 6. And so we can put a 10x in one box, and we can put a 6x in the other. And then what we do is we factor what's called greatest common factor. What does the 10x and 60 have in common, the greatest piece that they have in common? 10. X squared and 6x, they have in common an x. X squared and 10x, they have an x. 6x and 60, they have a 6 in common that they could take out. Notice x and 6 is my first factor. X and 10 becomes my second factor. And that is called a process of factoring. So let's look at what this looks like for a different type of problem. Okay. Now, again, some of you can recognize when we don't have anything out in front of this x, we're looking for two numbers that multiply to 12 but add to 7. Multiply to 12, but they add to 7. If I tried 6 and 2, because 6 times 2 is 12, but I add them, I get 8. Does not work. What about 4 and 3? Well, there we go. 4 and 3 is 7. And because there's nothing in front of that x, we can say that it has to be x with a positive 4 and x with a positive 3. Again, we could use the box method, and we're going to get the same results. X squared, our a value goes here, our c value goes down here. We're looking for two numbers that multiply to 12, but they also add up to 7. We already said that they were 4 and 3, so I'm going to put a 4x, and I'm going to put a 3x, and then I'm going to look for that greatest common factor. What goes into 4x and 12? That's a 4. What goes into x squared and 3x? That's an x. What goes into x squared and 4x? That's an x. What goes into 3x and 12? That's a 3. And there are those two factors. All right, so there's two different ways you can go about kind of factoring these. Why don't you pause the video here and see if you can't try to factor these two, right? Something times something, that factor times a factor. So go ahead and pause and see what you might get. All right, let's look at letter A. I need to multiply two numbers that are going to help me multiply to 20, but at the same time, those two values have to add up to 21. One of the common ones is like 4 and 5, but if you add those together, you only get 9. Well, 10 and 2. Well, if I add those together, I only get 12. Another way to get 20? Well, what about 20 times 1? 20 times 1 is indeed 21. So 20 can go here. 1 could go there. And it doesn't matter. I could have put 1 in the others. I could have flipped 1 and 20 around. X plus 20 and x plus 1. Maybe you tried the box method. Let's look at the box on the second one. The a value goes up top, so that's x squared. That c value is going to go on the bottom. Two numbers that multiply to 36, but they add to 15. A lot of times we think 6 and 6, but that only adds up to 12, so that doesn't work. Maybe it's 12 and 3. Well, lo and behold, 12 and 3 add up to 15. So let's put 12x down here, 3x there, and then find those greatest common factors. What goes into 12x and 36? Well, that would be 12. What goes into x squared and 3x? That would be x. X squared and 12x? That would be x. 3x and 36? That would be 3. So x plus 12 times x plus 3. You could have also said x plus 3 times x plus 12. You could have flipped them around and that would be okay. All right, now what happens when they get just a little bit harder? Just a little bit harder. For example, x squared minus 25. All right, well, if we look, the a value in this one is 1. The c value is negative 25. So what would this b value be if it's not here? It would be a 0. So I'm looking for two numbers that multiply up to negative 25, but at the same time they add up to what's in the middle, which is 0. How do I get two numbers to multiply to negative 25 but add to 0? Well, that would be a positive 5 with a negative 5. And so we could say x plus 5 times x minus 5. X plus 5 times x minus 5. In the second one, notice how all of a sudden the a value is 2, right? Everything else we've been working on so far, the a value was 1. There wasn't anything there. So we want to check for what's called a greatest common factor. Is there any number that will go into a, b, and c evenly? In this case, it's 2. We could divide by 2. That leaves me with x squared for the first piece. Negative 20x divided by that 2 is negative 10x. 18 divided by that 2 is 9. And now we can look at this part right in here. Two numbers that multiply up to 9 on the end, but at the same time they add up to negative 10. Well, positive 9 times 1. Positive times positive is a positive 9. That adds up to a positive 10. We need a negative 10. So what about negative 9 times negative 1? Negative times negative is positive, but a negative plus a negative is negative 10. So this parenthesis turns into x minus 9 times x minus the 1. Because those are the two factors that multiply up to 9, but add up to negative 10. And we've got to make sure that we bring that 2 out front. Okay, now why factoring? Like what is all of this for? Well, remember, when we had this factored form here, we could find those x-intercepts kind of quickly, which are solutions to our parabola. X equals positive 6, or x equals negative 4. But when they give us standard form, we can't find those x-intercepts just by looking at standard form. So if we're able to factor and break it down into something that looks like this problem, x plus or minus something, plus or minus something, we can then find those x-intercepts, which help us to graph, which also help us to then find the vertex and the axis of symmetry and the range and so much more. So that's why factoring becomes pretty critical to what we're doing here in the rest of this chapter. If you have any questions, please make sure that you reach out. Otherwise, until next time, everyone, stay safe.